Welcome back. We're writing Little Man Computer in C++. We've just started writing our assembler, and so far, if we have a look at the tests, we can see that we've handled just those instructions that don't take any address component. If we look at the samples in here, we can see that we have input, output, and halt instructions that don't actually have any value to them here. So the next step, I guess, is to evaluate the address component, and this is going to require us to have some sort of lookup for the labels to know where they point to. I'm not sure whether, I haven't seen in any of these whether it's legitimate to have an actual value in here. Well, it is, I would imagine, because in the context of a DAT statement. So we need to support both. At some point we need to support both having a string label and also a constant value in this column here. So which way round do we want to do this in terms of handling the value? It would seem sensible, I guess, as the value is stored as a string, to handle the string version first, and then we'll deal with parsing numbers second. So if we dive in here and create ourselves another test of some description. So that's the basic outline. We want to handle something like the add first, I would imagine. We'll do them in vaguely numerical order. So if we were to say assert, yeah, let's do this in two parts. Assert r equal, if I can type, expected program, and then we'll actually need to create an expected program as a vector of ints, which will be, let's call it 101. It doesn't really matter as such, but a non-zero value seems like it might be a good idea. Actually, 101 is not going to really work for us, is it? Because address 1 is going to be, let's call it 102, and that way we can address some DAT value, essentially implicit DAT value that's off the end of the program. So program assembler assemble, just throwing all of this in without running the tests. I think we're fairly comfortable now as into the structure of this. And we want an assembler. And we want a program of type instruction. Got instructions. And this is going to be an add instruction, which takes an address called A. Doesn't really matter what we call it for the purposes of the test, but A seems like a sensible value to play with. And then we have a halt with nothing in it. So there's a program which, if we run the tests, will not do anything interesting because I didn't save. Let's also give it a nice name, a single add instruction, and and a halt is translated to 1010. This is not quite the full test either, because we're going to need to just tweak the API of our assembler to allow us to start setting up. That's good. To start setting up some sort of lookup. So, where should we put this? Feels like we should be able to do something like assembler.add label A1 in our code, which we'll then be able to use when we go through and set these. Not quite. Set up these values, and there's no add label, which is precisely what we'd expect. So we can create an add label in assembler.h. That does nothing as a return value. Add label takes a const string. Does that matter? Let's do that anyway and see if there are any issues. And label end value, like so. That should then fail because there's no corresponding code behind implementing that header file. Exactly so. So we go in here to the C++ and have a void lmc assembler add label, which takes a maybe unused for now const string reference called label, and a maybe unused const int value, like so, and does nothing for now, which hopefully will. Oh, hello. It would be nice if I spelt things correctly as well. So that should still pass the test, still fail the test, but it should compile. And then we can start moving a step further forward. So we've kind of set the test up how we would like. We have, however, landed ourselves in a position where we can make the tests pass more easily than that. Now we have a failing test, we should just be able to do fetch back 101 like so, which should be the simplest way to make the test pass. Also, that's going to be wrong because 102 should be the answer. So how badly wrong have we gone? So the test is correct, the test name is wrong. Let's fix that first, and then we'll rectify our production code. Somewhat slow compiling. So that will now return 102 instead. And that should pass the test. Now there's an argument here that we have some duplication, as this 2 is also up in this value here. And I feel like we can justify, because of the simplicity of the code, doing something about that. Or can we? I think we're going to end up with something a little bit more complex here. Let's add another test. I think that would make me more comfortable. So I am going to brave copy and pasting, like so, and have a 103 value. The test's wrong as well. A is 2, here A is 3. So a relatively simple couple of tests there, but we're just making absolutely sure that the behavior we end up writing is going to be what we want it to be. So now we can go back to here and we can do something about this. And that's going to be a little bit more involved, because we are going to need some sort of lookup. Now, how do you do this in C++? C++ map data structure or something to that effect. It would be nice if that's just in the standard library. It looks like it is. That makes life considerably easier. I'm going to be somewhat lazy and just guess in the private section here that we can have something like map with a string and an int called labels. That hopefully will just work. We're not going to preset that or anything, but we will need to include map here. Let's just check that's correct. Might have an unused moan, or it might just work. Just thinking about it. In fact, the assembler's compiled, so that's not a problem. And so now what we should be able to do, hopefully, if I can find the correct API, is labels.insert. Oh, you insert as a pair like that. That's a really awkward API, isn't it? Why would you do that? Labels. Is that really how you do it? A pair like that? Well, if you insist. I feel like I want to try for having a look at an alternative reference, just to make absolutely sure. So insert is there not an overloaded thing that takes 2 parameters, or is it just too much of a pain? No, that is apparently the way. Well, there you go. So insert a pair of, this is where we discover the joy of C++, and it's very verbose typing on occasion. So does that do what we want it to do? Yep, that looks okay. And then we should just be able to retrieve the value. In some manner. Insert. Have we used the wrong data structure here? Is there not? Oh, that's just the insert thing. Insert. Oh, we can just do. Oh, that would be lovely. That's potentially quite useful. And in here, we will do 100 plus, note the complete disregard for error handling here. Instructions 0.address. Error handling may well be something we want to consider later on if we develop some decent feedback on the assembler issues. For now, that actually passes the test. That's very nice. Let us commit those changes. So our status is thus. So git commit. What's our messaging strategy? Our naming strategy, assemble single. So we can just say assemble add instruction. That would seem a reasonable thing to be able to do. Assemble symbol add instruction. Good. And if we go back here, I think we can get away with probably a single subtract instruction. I'm going to be brave and copy and paste a single subtract instruction. Translates to 204, and let's do that. And let's make sure we've got the right interpretation there. Let's be a little careful here. So we've got a label called S that points at 4. We have a sub and a halt, and we're checking for 2040. Good. That should just fail in a nice manner. And we should be able to do something very similar to the way that we dealt with addition. That fails correctly. So if we go here, we should just be able to say else if instructions 0.code equals sub program.push back 200 plus labels instructions 0. We are jumping slightly ahead of the very simplest implementation there. We could have just written 204, but it feels like that would be just slightly too pedantic in the TDD methodology. And I don't think there's really any need for that in this instance. That should hopefully pass the test, and we can see if there's anything nice we can refactor. So excellent, all of the tests pass, and we've reached 50 tests now. Very good. Now, what can we do in the department of refactoring? I think one thing we can do is we can pull out a current instruction, like so, which will remove a bit of duplication. That looks okay, doesn't it? So we've now removed that. Still passes, good. So we could possibly, no, just thinking whether we can pull out the pushback component here, or whether that's just overkill for now. No, I think we're not quite in a position to do that. What I would like to do though is just to shuffle the order of these things and start having them in their natural order. I'm imagining that we could potentially get to a position here where we just have a lookup table of the values, or the base values of these. So a table that given add will return 100, given sub will return 200, given imp will return 201. But then we would need to deal with the labels a little bit differently. Yes, I could say I could see a situation where if the label is blank, it has a 0 value essentially. Maybe that works. Do we push the boat out here and try something like that? Can we initialize a map in C++ in a nice manner? Yes, that's what I want to be able to do. That looks like something you can do. Let us have a quick look, just a little test here. If we could have some sort of static map that takes a string, returns an int called codes. That looks something like this. Don't know whether this will work, but we'll give it a stab anyway. One feels worth a little go, because there's a potential to. Ooh. Did not like that, did it? Let's just see if we'll get an unused variable potentially, but it seems to like that construction. So then I think it's worth just taking a little step at a time, and so we have instruction being code value equals codes instruction dot code. Can we do that? Is that going to break anything? Now we have an unused variable, but that's fine. Let's put a little break in there, and actually just give ourselves a bit more room around the evaluation of the individual instruction, like so. So that's fine. So we could potentially do this. That might work. Excellent. And then what we could also do here is we could say, oh, I almost want a constructor here. we be slightly... What if I were to do this? What if I were to do this? I don't know if it'll let me. But if I were to put in this, does that still work? So we've got automatic handling of blank addresses in this context. Then maybe we can do address value equals labels instruction.address, which may be 0 now, hopefully. Unused variable, I can live with that. And then we can do, we could potentially do address value like so, and does that work? And then we can probably get rid of our branching. It's been quite an ambitious refactoring here, but it's been step by step, making sure that we're continuing to keep things working. And then I believe this might work, which would be lovely. And I will be quite pleased with that refactoring. Series. We have an error somewhere. We have an error in the single halt instruction. That's fine, because it just means we need to add a halt, which has a 0 value. So we should just be able to retain our working status like so. Oh, we're going to run into starting to get a little bit wobbly here, as now we're going to have the single 0 is actually 2 zeros. I think that's a bit ambitious. What if we were instead to say if instruction.code is not equal to halt, then do this. That's a slightly safer and in keeping with the way we've been doing things structure, I think, rather than completely restructuring that. No? What is the issue here then? Well, I guess it would help quite a lot if we were to spell things correctly. But I think that might be the only remaining hurdle. Wonderful. That looks good to me. So we've got this little static lookup here. That's hopefully, if I understood the term static correctly in this context, won't be regenerated every time we call the assemble method. And then we create a program. We interpret our instruction, our first instruction. We see if it's not equal to a halt, then we get out the code value, the address value, and add them together to create our instruction value and push that onto the program. And then we stick a 0 on the end and return the program, and that seems to work completely fine. So, double check. Yep. So I think we can commit to that change. Symbol. So we're going to assemble a single subtract function with refactoring, but I think that's fine. Git commit -am assemble single subtract are we calling them? Instruction, yeah. So, instruction. Simple, single subtract instruction. Excellent. And I think we're now in a position to move on a little bit more briskly with these next time.